Everybody in the room had their car break down before? I'm assuming that everybody has experienced this. Sometimes it's a simple thing like a flat tire. Sometimes it's with an engine. Sometimes it's electrical. Sometimes we're at home and the engine breaks down, but even worse, we're out on the road and it breaks down. So I've learned through my experiences of having my truck break down is that it usually happens in the worst possible time. You're actually trying to get to somewhere using your car and it breaks down, and now your whole schedule's messed up and you're trying to figure out how to fix it. You're stranded somewhere, and you have to figure out how to deal with this issue. And if you would have done something different, maybe you wouldn't have had this issue. But typically it's very frustrating. People don't like it. It may cost us a lot of money as a result of it, and it's not an experience that we like, but we deal with it. Well, we assume that cars will break down, and that's the same thing we are at plants. Machines break down. We just accept it. And part of the TPM thinking, part of the lean thinking on this approach is no, it doesn't have to be. So we need to challenge that whole concept of machines break down, just deal with it, to what can we do to prevent them from breaking down? How can we do to better enjoy the use of the vehicle or the machine, and not have it always break at the worst possible case. So let's think opposite from the breakdown. Let's look at what would be our vision of nirvana, of heaven. What would it be like when we're at our facilities? What if we had a vision that there's no breakdowns ever on a machine, or that it's always running at the full optimum speed? We don't have to slow it down and baby it through its operation because it's an older machine or it's not working quite right, and we want to just not push it too hard, so we're going to slow it down. Or it always makes 100% perfect parts coming off the machine, that every time it cycles it's a good part instead of a defective part. We now have to figure out the reasons why, and that we also have a very clean workplace that's safe, and that we can be very efficient in running the machine. We should have some concept or vision that that is what we are after. So when you look at the approach of uptime, it's looking at how can we move closer toward this vision of heaven, of what we expect. And I would think that everybody should talk about what problems they do have in their current equipment setup and what they want their life or equipment to be like in operation in the future. And that becomes our target and goal going forward. And I'll add one more. In my experience, I don't think any machine that I know of is designed to leak, to have oil on the floor, water spewing out. Yet every single plant that I go to, my whole career, I see machines that leak. And it could be for various reasons, but there should not be any occurrences where machines leak. Yet every facility worldwide have machines that leak, and we accept it. So you see it on the floor around the machine. You see the leaks. You see kitty litter material, absorbent material, pads, everything around the machine to contain the leaks, yet the leaks persist. And I think, do you think these designers say, well, we're going to put this hose right here, but we expect it to leak. We're going to put this bad clamp here because it's going to leak. We're going to put faulty manifolds in because it's going to leak. No, I don't think it's designed. If you think about it, basically, if there's any fluids going through a machine, it's meant to do a purpose to operate that machine. So if you have less of those fluids or none of those fluids, or less pressure on those fluids, those machines are not going to operate the way they're designed. So we need to accept the fact that machines should not leak, and not accept the fact that they do and then just walk around it. I've been in plants where literally there was grease and slime all over the floor and on the machines, that you had to walk very slowly with anti-slip boots just to prevent falling over. It was like an ice skating rink. It was that bad, but it was accepted as the environment, and we have to say no, we do not accept that. So what do we do about it when we have situations like that? What do we do when we have equipment that's not running optimal? Let's look at what is traditionally taught is TPM, total productive maintenance. It's a very good, well thought out, very detailed approach to how to improve the uptime of machines. But if you look at the results of what I've seen and what you read about, what are the opportunities for it to actually be successful? And if I took a quote that I found on the internet, Ed Hartman, who's president of the International TPM Institute, he's quoted as saying at least every second attempted installation of total productive maintenance TPM results in failure. So at best, you got a 50-50 shot that this works. Well, maybe that's good odds in some people's thinking, but in mine, that's like complete unacceptable odds for my lean thinking. There should not be that great of a failure rate in doing something that is so well thought of and so detailed to help do something so needed. So what is it that causes this TPM not to work? And from that thinking, that's where we started coming up with the system of uptime to try to address some of those issues. So let's talk about some of those issues. First of all, it begins with top management, in my opinion.